This is the 8-4 lesson. Your objective today is that you will graph quadratics in the vertex form. So kind of the first thing that we should do to kind of help us address this objective is to determine what vertex form is. If you remember whenever we did absolute values and we kind of did those shifts and stuff like that, that's what it is. And so vertex form is given to us as y equals a x minus h squared plus k. And this is where h and k is the xy location, is xy of your vertex. All right. And if a is greater than 1, we have a vertical stretch. If a is, if we have 0 is less than a and it's less than 1, then we have a vertical shrink. And if a is negative, that tells us it's flipped. It's flipped or upside down. So those are some things to know for this, and we're gonna get a little bit of experience going through this. So starting off with number 1, if I have f of x equals -2 parenthesis x plus 2 squared plus 3. What we're doing is we're comparing to compare to f of x equals x squared. So the way that we do this is we read this from left to right, and as we do that, we'll be able to see each individual change. So the first thing I notice is the negative. Maybe I'll do these in colors. I'll circle it. So I notice the negative, and that tells me that this is flipped or upside down. All right. I continue on. The next thing that I notice is this 2. The 2 tells me that it's a vertical stretch because it's bigger than 1. I left out a T on there. Okay. The next thing I notice is this positive 2 right here. And why I noticed the positive on this when I didn't do it on the other ones is because of the equation a equals x minus h squared plus k. And so that minus h tells me that it's kind of going to be whatever the opposite is of that 2. So that positive 2 tells me that I go left 2. Okay. And the final thing that I notice is this positive 3. Again, I'm kind of taking note of that sign because this is also a positive, so because they match up, it just tells me that this positive 3 means that I go up 3. All right, let's do another one. If I have g of x equals 3 x minus 1 squared plus 6, again, I'm going to go through, and the first thing I notice is, hey, I have a 3. This tells me that, and actually maybe it'll be better if I do it in black, just so it matches up. I have a 3. This tells me that it's a vertical stretch. And you might be like, well, where's the green one? Where's that sign out front? Because it's positive, it's normal. Alright. Then I go and I look at the, oops, not black, gray. Then I go and I look at the next one. And I say, okay, -1. And so that -1 tells me that it's right 1. The next thing I see is this +6. So that +6 tells me that I'm up 6. Number 3, if I have h of x equals 1/2 x plus 4 squared minus 2. Again, I look out front. Oh, there's nothing there, so it's a positive, so that it says it's normal. The next thing that I notice is the 1/2. Because it's less than 1 and greater than 0, the 1/2 tells me that it's a vertical shrink. Alright, continue along my way. I find this +4. So the +4 tells me that it goes left 4. Moving along, I find the -2. And the -2 tells me that I go down 2. Okay, number 4. R of x equals -2/3 x minus 7 squared minus 5. So I go through, and the first thing I see is this negative. The negative tells me that it's flipped. Okay, next thing I find is this 2/3, which tells me that it's a vertical shrink. Next thing I find is this -7, which tells me right 7. And finally I find the -5, which tells me down 5. Okay. And one thing I wasn't really telling you guys is this left 2, up 3, this is the vertex for each thing. So my vertex is left 2 and up 3 from the origin. And that's the right 1, up 6. That's right 1 and up 6 from the origin. That's where your vertex is located. The reason that's handy is on number 5. It wants us to write a quadratic function in vertex form, where the vertex is 3, 5, and it goes through a point 6, 0. So if I set this up, y equals a x minus h squared plus k. My vertex, my 3 is my h value, my 5 is my k value, and I don't really know where to put this 6 and 0 quite yet. And so I'm going to plug things in. So I get y equals a x minus my h value, which is 3, plus my k value, which is 5. Oops, this has a squared on it. Now I'm kind of still at a spot, and I have 3 unknowns. 2 of them I should expect. I'm like, okay, y, yeah, I should have, and x, yeah, I should have, but I have this a, and so I don't really know what to do with this a. And so what I'm going to do is I'm going to plug in 6 and 0, because it's a point that's given to me. So 6 is my x value, 0 is my y value. So I'm going to do 0 equals a, my x value, which is 6 minus 3 squared plus 5. And now I can solve this. And so I go, all right, 0 equals a 6 minus 3 is 3 squared plus 5. Subtract 5 from both sides. I get negative 5 equals a 3 squared is 9. And I divide both sides by 9. And so I get a equals negative 5 over 9. Okay. And I'm not quite done. It's really tempting to get to this point and you'd be like, okay, I'm done. But what you need to do is you need to go back and you need to plug it into the equation. So we leave it in this kind of generalized form of just having the y equal my a value, which is negative 5 over 9, parenthesis, x minus 3 squared plus 5. And this is your final answer. Number 6, write a quadratic function vertex form with a vertex of, so my vertex is negative 2, negative 4, and goes through the point negative 1, comma 6. So the generalized form is y equals a x minus h squared plus k. Here's my h. Here's my k, here's my x, here's my y. And so I go y equals a, I don't know my a value, x. Now, my h is negative 2, and so maybe the first time around it's kind of easier to do this. Squared plus my k value and then I can kind of evaluate it and go, okay, y equals a x plus, actually maybe I'll make that in green, plus 2 squared minus 4. And I go, okay, I have this a value again, and so I need to plug in my point, negative 1, 6. So I go 6 equals a, my x value, which is negative 1 plus 2 squared minus 4. And so my first thing is, I have this negative 4, so I add 4 to both sides. So I get 10 equals a negative 1 plus 2 is 1 squared. 1 squared is 1. So I have 10 equals a times 1. I divide by 1, and so I get 10 equals a. So I put this in my equation. So y equals, my a value is 10, parenthesis, x plus 2 squared minus 4. Okay. Let's do a graph. So if I have f of x equals x plus 1 squared minus 7. To start off, we have our axis of symmetry. We need to find our vertex. We need to find our y-intercept. And we need to find our zeros, or our x-intercepts. Now, when we're in vertex form, it's a lot easier to just start with what's the vertex. Because we know that y equals a x minus h plus k. The h and the k, h comma k, is our vertex. So my h is -1 and my k is -7, because this says, okay, it's the opposite of it. It's opposite of what's given in the general, and so we have a minus. And so my vertex is -1 comma -7. My axis of symmetry is my x value of my vertex, so my x equals -1. My y-intercept takes a little bit more work because I know, okay, my x needs to be 0, I need to figure out my y value. So I go f of 0 equals 0 plus 1 squared minus 7. And so I get my y value, f of 0, equals 1 squared is 1, minus 7 is -6. So it's 0, comma, -6. My zeros, or my x-intercepts, are a little bit more difficult, because what I need to figure out is when I have my y value being 0, what is my x? So I go, okay, 0 equals x plus 1 squared minus 7. And what we can recognize here is this is no different than what we were kind of doing in the warm-up today. We go plus 7 to both sides, and we get 7 equals x plus 1 squared. Now I do the square root. I do the square root. I'm going to flip sides at the same time. So x plus 1 equals plus or minus the square root of 7. And 7's a prime number, so we can't really evaluate that any lower unless we had a calculator or knew that value. So we subtract 1 from both sides, and we get x equals -1 plus or minus the square root of 7. So my zeros are -1 plus the square root of 7 and -1 minus the square root of 7, comma 0. From this, we can also make a table of values, an XY table of values. I'm going to start this at -1, -7, because that's my vertex. And I'm going to go in both directions. So when x is 0, when x is 1, when x is -2, and when it's -3. So when I plug on 0.
Sarah Gosling, please go to the counseling office. There's someone waiting for you. Sarah Gosling, thank you.
So when we do this, we have a 0. We plug that in. So 0 plus 1 squared minus 7. And 1 plus 1 squared minus 7. And -2 plus 1 squared minus 7. And -3 plus 1 squared minus 7. And I can just figure out this is 1 squared is 1, minus 7 is -6. 1 plus 1 is 2 squared minus 7. 2 squared is 4, minus 7 is -3. And these are going to be the same values because they're the same distance from -1. And so now I can graph this. Two shapes this. Needs to go down 7. That should do it. So I go to -1, -7. Change my color real quick. -1, -7. 1, 2, 3, 4, 5, 6, 7. 0, -6. -1, -7. 0, -6. -2, comma, -6. and 1, negative 3. 1, 2, 3. Negative 3, negative 3. 1, comma 3, negative 3. Negative 3, comma negative 3. And we have ourselves a little graph. Just like that. Alright. Let's do another graph. Great. If we're given g of x equals negative x plus 4 squared plus 2. Now again, this is in vertex form, so I can just base it off of, okay, this plus 4, is telling me the x value, and this plus 2 is telling me the y value. And so, okay, yeah, I have the axis of symmetry, and then we're going to have our vertex, and we already know what our vertex is. Our vertex is negative 4, because it's the kind of the opposite of what's happening in there, comma, positive 2. I don't know why I started to write that positive. A positive 2. And so we're able to get that our axis of symmetry is x equals negative 4. And then we have our y-intercepts. This is when x is 0. What is my y value? So I do g of 0 equals negative 0 plus 4 squared plus 2. So g of 0 equals negative 0 plus 4 is 4. Squared is 16, so negative 16 plus 2. So my g of 0 is negative 14. Now I need to do my x-intercepts, or my zeros. And this is when y is 0, what is my x value? So I get 0 equals negative x plus 4 squared plus 2. I'm going to subtract 2 from both sides. And so I get negative 2 equals negative x plus 4 squared. And you get rid of the negative, so I divide by a negative. So I get 2 equals x plus 4 squared. Get rid of the squared, so I do a square root on both sides. Gotta flip the sides at the same time. So x equals, x plus 4 equals plus or minus the square root of 2. Then I subtract 4 from both sides. And so I get x equals negative 4 plus or minus the square root of 2. So I do negative 4 plus the square root of 2 and negative 4 minus the square root of 2. So I do an xy pair, xy table. I'm going to start at negative 4 because that's my vertex, and go from there. I'm going to do negative 3, negative 2, negative 5, negative 6. And what you'll kind of find with vertex is if you don't have a number that's right next to it, it kind of makes it a little more work, especially when you start looking at the square root type stuff. So I do negative 3 plus 4 squared plus 2. So negative 2 plus 4 squared plus 2. Negative 5 plus 4 squared plus 2. Negative 6 plus 4 squared plus 2. With this, negative 3 plus 4 is 1. 1 squared is 1. Make it negative. It's negative 1 plus 2 is 1. Negative 5 is going to be the same thing. Negative 2, so negative 2 plus 4 is 2. 2 squared is 4. Make it negative. We get negative, negative 4 plus 2 is negative 2. Now we can graph this. And so negative 4, 1, 2, 3, 4. 2, 1, 2. Negative 4, 2. Negative 3, 1. Negative 5, 1. Negative 2, negative 2, 1, 2. Negative 2, negative 2. Negative 6, negative 2. Okay. Alright. This concludes everything. Check with your teacher on your assignment.